Good afternoon, folks. Welcome to live stream number 12. Thank you all for joining us in this most strange time for our country. I hope you're all doing well. Um, and for those of you who haven't read the description, this session is going to be mostly a Q&A session. So if you've got any questions about how to run a CNC, hopefully we can answer them for you. I've got a couple topics queued up, so I'll just start running through that. If you have anything relevant to what I'm talking about now, feel free to just jump in the chat. Otherwise, we'll have an open Q&A at the end, and yeah, let's start by answering some questions. Let's see. Hello, everyone. Hello, Marcus from Canada. Will Luke from Beaver CNC sell his touch probes via Carbide 3D? Well, we have a touch probe already, so that is what we sell. Is it possible to carve over-length pieces on a Shapeoko 3? Totally. The thing is, you need to learn how to partition your work. So let me demonstrate, or not demonstrate, but let me show you what I'm talking about. So if we have, I don't have a really large, all right. Let me know if my audio sounds terrible, by the way. This is a work in progress. But same audio settings as last time, so it shouldn't be a big deal. Let me jog up and get the spindle out of the way. So if you want to cut something that exceeds the travel of your CNC's bed, do I have a Sharpie here? I do not. I am so unprepared. Unfortunately, no writing implements here. Hopefully someone will come save me, but I don't think that's going to happen. So if you have, let's say you're trying to carve out someone's name, a giant bit of word art, you'd have to be able to separate the text that's over here from the text that's over here. And it's difficult to do this in Carbide Create because you can only cut on closed contours. So if you have, like, let's say an oval, you can't just stop the toolpath arbitrarily at a certain point halfway along that horseshoe shape. Perfect, someone is a savior. So let's say you're trying to cut out that oval that extends past the cutting area of your CNC. You'd have to find some way to partition the toolpath to stop it somewhere so that you can then reverse that workpiece or slide it forward and backwards, reacquire a 0 coordinate, and then use that coordinate to determine where the rest of your toolpath will fall. Usually, if you can machine some locating pins or features in your workpiece as you're machining these, you can tile this out. Or if you have a perfectly rectangular piece of stock, you could maybe throw a touch probe on the corner, flip it around, and then use a touch probe to relocate this corner so you can machine this half. It all depends on how you're doing it. I know Vectric supports tiling. You can kind of hack this in Fusion 360. I don't recommend it. But if you want, afterwards, someone remind me, I'll show you a setup for how I helped one of my friends machine a big sign for one of his friends. So that is double-sided, basically the theory behind machining in multiple sections. Let's see. Happy Friday. It is thankfully a Friday. I could definitely use a weekend. Okay. Would it be a good idea to initialize between tool change paths when moving stock? My depth X and Y shifted a little when tiling. You shouldn't need to reinitialize anything unless you've like jostled the CNC or moved it or bumped it in some way. Usually the thing I see happen is when someone's changing tools, if you do it with only one wrench and you just use the spindle lock button and you are torquing on the spindle, you're also applying a lateral force. So you can bump the stepper motor and shift it a step if you really force it. By using two opposing wrenches, you cancel out the lateral forces and you get pure torque. So using two wrenches prevents you from accidentally ripping the CNC, forcing the stepper motor to miss a step. That's usually the only case where I would see an issue with a misalignment. The other thing is, if you have a, pretend this is wood, it might be bowed, it might be cupped, it might be warped. So when you flip it, one corner might be lower than the other, and you might get some subtle differences in how your shapes line up or the depth of cut. But if you set the reference to your wasteboard, at least you'll know you'll cut all the way through whatever it is you're machining. Okay, there are some other programs out there. If you know of any good software for tiling, do drop them in the chat, because I would love to learn some other options as well. All right, so without further ado, let me load up my to-do list of questions. So first up, this is a holdover from 2 weeks ago. Someone asked, what is my dust collection setup? So let me zoom out the camera and show you what I've got going on here, which is really rudimentary. Just ignore like everything dangling. So I'm on a tether here because my microphone is only like 5 feet long. So I'm going to pan down a little bit so you can see what's going on here. I have, just don't mind that, a vacuum. You could use a shop vac. You could use a fine or a Festool. I personally like the German ones because they tend to be a little quieter. They're a little more expensive, but you get what you pay for. This is hooked up to a dust separator. So this is just a Home Depot. It goes on top of a bucket. It separates things. It's like 40 bucks. It's okay. I personally like the Cyclone, the tapered conical ones. I think they work a little better. These are a little cheap. They don't seal very well. I had to put packing tape around the rim of it. But if you have a really strong shop vac, you can get some good circulation. It'll fling the dust to the outside. With a smaller, more modest vacuum, I feel like it's not as effective, but it does the job. Dust separators will really save your vacuum because this has a limited capacity and the fine dust will clog it. Dust will fall out here. It doesn't clog the tubing. It doesn't clog a filter. So this saves this. I highly recommend having something in series before your vacuum coming off your CNC. In terms of, let's pan up. And let me also check the chat to make sure nothing terrible has happened in my absence. Nope, too far. Okay, quick check of the chat. I have, coming out of this little dust separator, I go up to a hose and I just have a little arm made out of 2x4s, so a basic 3-inch hinge, a little gate spring, just to keep it from just flopping around in the forward position. And then just this goes into my sweepie. So that's just a really like a $10 solution to keep my dust hose in check, make sure I'm not dragging on my router, and it just keeps everything relatively easy, and I can just sort of yank the hose out here if I need to clean up the floor, like if someone throws confetti all over my workspace. And then, yeah, so that is my dust collection setup. I have a different dust separator at home, but this is the same basic setup I have. I still use the gate hinge, and it works out pretty well. The only thing you have to keep in mind is that the radius of that dust arm that swings out, you have to make sure you have enough slack for the hose to be able to reach every corner of your CNC. A nice flexible hose would be even better, but this is what I got. This sort of ties into the next question, which is how do you deal with static buildup? Because as you're collecting dust, those dust particles travel through here. It basically turns this into a little Van de Graaff generator, and this whole thing builds up a pretty sizable charge, and that can cause issues with disconnects and other just electronic problems. So one of the reasons I stole this from a festival is their hoses, I believe, are all grounded. So when you plug this end into a CT or any other extractor, it's actually got a contact that touches this, and it prevents a charge from building up along the hose. I have seen just dust building up on this before, like a big fuzzy coat. And if I take just a metal wrench or something and I touch the hose, all the dust just falls off. So I have recommended before, like if you have severe EMI issues, try just wrapping a bare copper wire around your hose, grounding it to a large block of metal or to like a spike on the dirt, and hopefully that will help dissipate any charges that build up on your hose. And also physical isolation of the hose from the gantry and the other, well, mainly just the gantry or whatever your electronics are mounted to, can also help. If you have just a hose that's dangling over this, it's transferring that charge into your machine. So being able to suspend the hose and keep it off the rest of your machine is also helpful. In terms of EMI routing, for the router, I've had someone ask this: how do you arrange the power cable coming off your router? And they're wondering, like, which way should it go? How do you make it avoid all the cables? You can't. But the cable that matters is the USB cable, because that's the only one carrying data. If there's EMI going into a stepper motor or a limit switch, that's not as big a deal. So it's really just, if it's an issue for you, try routing the router cable in the opposite direction away from your USB cable. Other than that, it can be in contact with whatever. Doesn't matter too much. Okay, this is from another question: how to check limit switches to make sure they're working or not. I'm going to switch back to the desktop view after I pull my face down off the feed. So in case you don't know, or in case you need to contact support, it is pretty easy to check if your limit switches are working. So even if you haven't initialized your machine yet, you can still access the settings page, and then over here under Gerbil active input pins, if you just touch a switch there, it'll show you which axis is lit up. So here I can see the x-axis can be lit up. I don't know if I can get to the z-axis because it's behind the carriage. Maybe this little wrench will do. There, so we can see Z lit up. And so you can just do a quick check to make sure that all three switches are working in case you're running into any homing issues, or your machine's misbehaving or stopping, or like in the middle of a cut you see like, oh, homing fit. Like if something weird is going on and it's linked to homing switches, you can check the health of all your switches through this Gerbil active inputs panel. So that is an easy thing you can do. Let me check on the chat, make sure everyone is okay. Let's see, any idea when an 80mm sweepy might be available? I think sweepy, everything sweepy in general, we are just waiting on some supplies right now. Hopefully it is soon. I'm hoping this month, but fingers crossed, we shall see. Let's not test the confetti theory. I have been traumatized enough on these live streams. Yeah, this Desto support arm is actually, I've been really pleased with it. At home, I actually split this up into 2 linkages just for a little extra bit of articulation, because what you'll notice here is this can swing out, but for the hose to go all the way back to this back corner, the hose has to just go all the way here, whereas if you have a 2-link design, this can fold in on itself and bring this end of your arm back over to the back right corner of your machine. But like really simple hardware solves a lot of problems. Okay, let's see if we have anything else on the Q&A question list. So this is a question we get asked a lot by prospective customers is limit switches versus, or not limit switches, travel versus clearance. So let me get this out of the way. The Shapeoko, Nomad, whatever, they're all advertised with about 3 inches of X travel. So your workpiece can fit within a 3-inch range, and then that will determine like where on the machine you can place something, but it doesn't tell the whole story. Because if I measure underneath the gantry or the carriage, right now I'm rating about 4 inches. So you could fit something that's 4 inches underneath the gantry of the machine, but the router can only move up and down. I think it's about 3.5 inches if I measure the top and the bottom together. So those discrepancies often confuse new users. So you can fit something taller than 3 inches on the bed of your machine. The problem is not only is your travel limited to roughly 3.25, 3.5 inches, but your tool length also determines what it is you can machine. So if you have something, I'm looking for something large, and this will do. Let's not show brand names, even though this fine beverage is quite tasty. If you want to machine something really tall, you could, and this could fit under the gantry, theoretically, let's say I just remove this board, you are limited to, practically speaking, what your end mill can machine. Let me switch back to the main camera view just so you can get a better view of what I'm talking about. So if you have a, let's pretend this is 4 inches tall, that would fit under the gantry, theoretically, but you only had an end mill that could cut about 1 inch, well, you could machine the top quarter of this, but you couldn't machine the rest of it. So even though something fits doesn't mean it's machinable. We have a lot of people asking like, hey, can I mill like a guitar body in one shot? And the answer is yes, but you'd need to find a tool that would go all the way through whatever material you have. And those are kind of hard to find. You can find them, but they tend to be longer tools, a little more specialized. And the length of the tool that you can utilize is restricted by how much travel you have. Because if you had a 6-inch end mill, but it can only change its height by 3.5 inches, then you can't use that full 6 inches of that tool. So in theory, you can machine anything that'll fit here, but you can only machine a slice of it, a layer of it, that is the length of your travel. All right. If you need a longer end mill, they are available. I often point people to Lakeshore Carbide. They have a decent selection. They're reasonably priced. There are others as well, but I usually point people to American manufacturers that I have personally used. And the thing to remember with those is that the longer an end mill is, the more it's going to be prone to vibrating, and the more fragile it's going to be. So if you imagine if you're holding a piece of spaghetti and you have a very long piece of spaghetti, it doesn't take a lot of resistance at the tip to just snap that piece of spaghetti. But if you have like a 1-inch length, it actually holds up to a good bit of force. So the longer an end mill, it's a little more fragile. You probably won't, like a 1/4 inch extra long end mill, you probably won't break with a Shapeoko. 1/8 inch is definitely in the realm of tool breakage. But for tools like that, you would want to back off on your speeds and feeds, let's say 20% or more, but it's a decision you'll have to make as you go through things. All right, so that is travel versus clearance. We have first 5 items checked off. Let's check the chat. Could you use a Surface Go as a controller? You can use any machine that is running either a full build of Windows or Mac OS. Do they still do Windows RT or whatever their Surface version is? If Surface Go is a full build of Windows with a USB port, you can use it. But I am not entirely familiar with how the Surface line has evolved, even though I use a Surface 3 a lot. Okay, let's see. I noticed on the bottom end of the linear rails on the Z Plus that black streaks are forming. All right, so this is a video I haven't done yet. Let me pull the gantry closer to the front so it's a little easier to talk about. And let me move the carriage to the top. And then let me try zooming in. I don't know how well this will work. So here you have a Z Plus, and I am blocking the studio lights. These are linear rails with bearing blocks, and these are generally packed full of a light grease that provide lubrication. So as they travel over the rails, the silver parts, they'll deposit a little bit of oil, and that will help keep things lubricated, keep things moving smoothly, and also help prevent corrosion. This is in the way of my talking. As they go up and down, though, because these rails are lubricated, you can pick up small dust particles that will stick to it. Or if you're cutting wood and you don't have dust collection, you'll see some particles or sawdust sticking to these rails. Generally, that isn't a problem. There's a rubber little gasket around the face of these bearings that will sort of just wipe or squeegee off any dust that gets on there. Over time, as dust particles cling to these rails and get pushed off, they will wick away a little bit of that oil or grease. So eventually, after, depending on how heavily you use this, it could be years, it could be months, you'll want to take a little syringe, fill it with grease. There's a grease port on the tops of these blocks, and just inject some more grease into there. But if you take a finger and you wipe the rail and it's not bone dry, there's still a little bit of lubricity to it, you should be okay. So for the most part, these are maintenance free, but if you're a super heavy user, within a year or two, you might get to the point where, hey, these rails are dry, and maybe the bearing blocks are a little squeaky. Hopefully it doesn't get to that point, but that would mean that you'd want to reload these with a little bit of grease. But a little bit of black on the bottom of these just means it's a little dust that might be sticking to it, or sticking to the grease that's on the rails. Not a big deal, not a problem. So let me wipe my hands of that mess, and let us carry on. Loud car outside. Hopefully you guys didn't pick that up. So let me zoom out a little bit and check the focus. Looks about right. So we had a question about what is the cost of entry to get a CNC up and running? What do you need? Give us like total price. So that's a fairly straightforward question for a basic use case. CNC itself starts at I think about $1,200. So anywhere from like $1,000 to $2,000 for a machine of this class will get you started with the router. Round up a little bit, about $100. Depending on accessories you want, like a tool length probe or a bit zero, a touch probe, factor in another $100 to $300. And then the other big item to go with a CNC machine is end mills. So I have the luxury of being able to raid the supply cabinet. So this is like all the end mills we carry, plus a couple others. Depending on what you need for your project, you could spend like 20, 30 bucks, get just the end mills you need, and then over time add more. There are people who want to like drop $200 all in one shot. I always advise them to get a project first that you can work towards. Otherwise, you're going to start buying everything, and half of the tools you're not going to use. I actually have a drawer at home filled with end mills I bought before I knew what I was doing, and they have never been used, and I don't know if they will ever be used. I have some high-speed steel end mills that they're just really not as good as plain carbide for what I'm doing. So start with just a basic set of tools. Like if you're making a small sign, get some 1/8 inch, get some 1/4 inch end mills, get some V-bits, and then make your project. And then as your skills and your projects grow, then I would start adding tools to your inventory. So I would allocate no more than like $100 to $200 for tools to get started with. You can also get one of our starter kits of Amana tools if you so choose. But a couple basic cutters to fit your initial needs is what I would recommend first. And so all of that should keep you under $3,000, let's say. The other ancillary stuff, like a table, which you will need a workbench, a nice sturdy workbench. Some drawers is nice if you want to just throw stuff in there. A shop vac, a dust separator. Those are other things that people don't initially think about, but dust collection is something that should be something you start thinking about as soon as you put a CNC in your shop. So those are some just secondary things, but they all go into the CNC experience, and they're worth looking into from day one, or really day zero when you first purchase the machine. Okay, let me check. Do we have any other questions on that front? iPad Pro as a controller, it would be interesting. The problem is Carbide Motion is not going to run an iPad, and you also need to connect it to a regular USB port. If someone writes there are third-party apps for running Gerbil-based machines. Like you can run a Shapeoko off a Raspberry Pi. You just need something that will transmit G-code to the controller. As far as I know, there's nothing out there, but we don't plan on having an in-house solution for doing that. If you're doing signs, the 60-degree V-bit is a must. I agree. So V-bits come in a couple different angles. Like this is a 90. I know you can't see it. 60 is pointier. The pointier it is, the deeper and more precise your cuts will be. But a less tapered angle will cover, like if you're cutting like a large letter with some wide areas, like let's say the letter I at like a 200-point font. A 60-degree bit will have to plunge so deep to hit both the edges that it's actually going to potentially take longer or cause more stress on your CNC because those V grooves have to touch both edges of the feature, the letter that you're machining, unless you use advanced V-carve, which is in Carbide Create now. So it basically does, it's a hybrid between V-carving and pocketing. Okay. Is there any other software not in the Shapeoko? Do we use like a milling machine with manual control of the X, Y, and Z axes? Right now there is not. You could do jogging. It might help if you hook it up to an Xbox controller or something, because we do have controller support. But at this time there is not a good way, like you can't just crank a wheel and jog this thing like a milling machine. Would be cool though. Can you use a surfacing bit like the 6210 white side with the bit setter? Let me look that up. I think that's the 1-inch tool. White side 6210, 1/4-inch shank. Okay, so that is the 1-inch surfacing bit. I will flash it up on the screen briefly. So this tool, 1-inch diameter, 3 teeth. They will work. You have to look on the, so actually let me flip back to this. In the center of that tool, there is a recess, and it will just barely touch the outside edges of the bit setter. So there's a little pin on the bit setter that the tool touches off of. That should be hit by the, like it shouldn't be, the diameter of the pin is large enough that it shouldn't fall between the teeth of the cutter. That being said, there is a slight chamfer on the bit setter pin, and that could cause an incorrect height to be detected. The best thing to do if you have an oversized tool like that is to actually shift the bit setter so that it's offset, so it's not perfectly centered with that depression in the surfacing tool. so that one of the teeth is guaranteed to hit the top of the pin. Not always practical because it requires the tool being deliberately not centered on the bit setter, but you can do that. I have mine offset by about 1 millimeter or 2, and then when the bit setter goes to touch off, I make sure I rotate this tool so that one of the teeth is directly over the pin. Okay, how's the chat going? Let's see. Is the supported control only for Xbox? It is for Xbox or any Xbox style generic controls. So I actually have this no-name controller, same Xbox shape, USB connector. Doesn't work for Mac yet. We're still working on that. Mac handles the inputs a little differently. There's also a Logitech controller design that's pretty popular, which is also compatible. Okay. Let's see. We don't have any macros, so you can't set something up to drop 4,000 and run it past 3 inches to the right. So something as basic as that, you might be able to accomplish using the machine dialog interface. So you just type in like G1Z minus 0.004 or something, and then G1X whatever to move however many inches. Those are some things you can probably copy and paste, but it is, we don't have macros built into Carbide motion. Can you talk about mounting stock on the front to mill dovetails? Sure. So right now, Shapeoko has a bit of overhang capability. You see it when you change a tool, it comes in front. If you want to hold stock to the front of the machine, the newer machines, they have a little bit of a lip here that extends up, I think, 3/4 of an inch over this MDF. So you could either take a large board and clamp it to the front base frame, or what I've done before is you build up a little MDF platform here that extends out so that you can clamp a stock to that front face without hitting this. Different ways you can clamp it. You can either just take like F clamps or something, or you could actually put some threaded inserts into a block here, or like use a 1, 2, 3 block and then bolt or clamp to that. And then making toolpaths to cut dovetails, like to just slot through a board, that's up to you. You could do Carbide Create, Fusion. Basically, you just need a cutter to move in a line forward and backwards. Can you let us know what Carbide shirt you are wearing today? I certainly can. You can feast your eyes upon, microphone's getting stuck, this design, not for sale anywhere, exclusive to Carbide employees. Be jealous. Maybe if you win or participate in a Carbide 3D community challenge on our forums, that could potentially be a piece of swag. Sorry, there's no love for PlayStation users. That being said, if there's enough, if you have enough interest, drop it in the forums, and we can consider that. We're open to developing for other controllers that people might use. So, I think that exhausts the chat questions for now. Let's go back into the my list of things to answer. So someone asked if you can machine aluminum on a Shapeoko. The answer is heck yeah, you can. And I had an idea to maybe actually just machine a small pocket here in aluminum, but I haven't tested the G-code. So this could end terribly, but I think a live demo might be kind of fun. So let's set up for that. So I have an adaptive clearing toolpath that I made in Fusion 360, and it should cut a 5/8 by 3/4 inch little pocket here that's radius, and it might work, it might end terribly, just because I haven't tested these parameters on this machine, which is, I haven't fully tuned this up, so something could go wrong. But yeah, let's go for it. So I am going to load a new file with my aluminum testcut.nc G-code file. I have already preset my 0 about here, so let me double check that by returning to my current XY offset, and then Z plus 6, so it should stop right there, 6 millimeters above this surface. So we'll hit done. We will go back to the run screen. We will start this job. Hit start. And then let's do this with the bit runner. So I will turn on the router, set the bit runner to auto, and then I will transition to just the camera view, so you can't hit me hovering over the pause button here. And then I'm also going to take the precaution of just, covering my laptop in cardboard, because this is not going to be fun for me. I'm going to just zoom out so you can have the fun of mocking me. Here under my cardboard shield, hit resume, and I'll keep my fingers crossed. I'm going to drop the microphone volume just a little bit, but just enough so you can still hear the sound of the cut. All right. So it should be helixing in right about now. So I don't know how well you can hear me right now, but the tone of the cut is relatively even. It doesn't sound like a helicopter over the roof. We're looking, I'll just talk for it. This will be done in like 20 seconds. Okay, so let's talk about what just happened. Let me zoom in, let me take the workpiece off. So one of the other questions that people asked was, what should a good cut sound like? And you're looking for a nice consistent tone without any like sort of macro scale issues. Like if you have chatter or like vibrations that are about on the frequency or the intensity of like a helicopter hovering over your house, like you can hear that repetitive thumping, or like a machine gun, like vibration on that scale is low frequency enough that it indicates that your machine itself, the router, is vibrating, rather than like a high-pitched either screeching or grinding, which would be happening more at the end mill. But either way, the tone of the cut should be consistent all the way throughout. So if you hear anything, or even see, sometimes you can see the machine vibrating if you get a cut really, really wrong. But for the most part, it should sound the same regardless of where it is in the cut. In the corners, you'll have some other things going on, but it should be, all right, zoom in closer, it should be relatively consistent. So this is the pocket that I just milled in about 50 seconds. Center it. Let me see how close I can bring it to the camera so you guys can see it. So no drama, pretty straightforward. But so sound of a cut, sorry about that clank, should be there shouldn't be anything weird or make you scratch your head or wondering if the machine's going to rattle itself to pieces. So let me check the chat. What end mill did I just use for that cut? It was a coated end mill. Let me pull that down for you guys. It is our 278 single flute. Let me put my wrenches. Literally had them Right. So this is our 278Z single flute. I personally am infatuated with single flute end mills because for every revolution of the cut, they only impact the material once. So the thing that's important with aluminum is speed. You want the edge of that tool to be as fast as possible within reason. But the faster an end mill spinning, the more times per second it's going to hit your stock. So a 3-flute end mill is going to be impacting 3 times per revolution. It's going to, in theory, take 3 times the amount of torque for the same RPM. So single flutes let you hit the material really fast while putting the minimal amount of force back into your machine. So that is the 278Z. The parameters were, I think, 46 inches per minute, 18,000 RPM. Depth of cut of 0.06 inches, so about 1.5 millimeters for you odd international folks. And a optimal load, so what fraction of the width of this tool into the material. It was 0.012 inches, so just over 1/4 millimeter. So the gantry moving, if you're using Carbide Motion build 500 or above, the default speeds and feeds that are sent to the machine are not the speeds and feeds. The default feed rate limit when you change, like when you send your configuration data to the machine, it raises the maximum allowable feed rate to 10,000 millimeters per minute. Previously it was 5,000, but I twisted the arm of my boss a little and had him concede that the machine is capable of handling, when it's not cutting, feed rates faster than, that was the equivalent of 200 inches per minute. So 10,000 millimeters per minute is about 400 inches per minute. So if you download Carbide Motion 5 and you send configuration data to your machine, it will overwrite the previous speed limits and raise it to 10,000 inches per minute, or 10,000 millimeters per minute. So that's why you see this zipping around when it's not cutting faster than you might be used to. There is a setting to change the speed of the homing function. This is something of an advanced thing you can do. Someone asked how you can modify Gerbil settings, and this falls under the same category. My boss is going to hate me for pulling this up because, let me preface this, if you don't know what you're doing, just ignore everything I'm about to say. But the Gerbil settings are sort of the underlying, like behind the scenes, these are the numbers that control your CNC. So the maximum feed rate is saved in parameter 110. The maximum feed rate in Y is 111. So those are the values that are changed when you upgrade to Carbide Motion 5 and push fresh values to your machine. If you, let's see, the homing function is parameter 25. So that's 500 by default. Historically, it used to be 1,000. When we came out with the double XL, we realized that people were spending a lot of time waiting for their machines to home. So we bumped it up to 2,000. And if that's not enough, you can bump it up just a little bit more to like 2,500 or 3,000 millimeters per minute. But it's not something we would advise, just because you increase the risk of the machine crashing or breaking something. So if you need to change a setting, which you should not, let me stress, this is not an essential step. In the MDI, you would type $ for, in particular, homing speed, 25 equals 2,500 or something. And if at any time you screw something up, you can always go back to settings and then resend the configuration data. This overwrites everything with the defaults. So please don't touch this unless you know what you're doing. You can really mess up your machine that way. All right, so I have the bit 0 and just acquired the bit setter. What is the sequence to start a new job? All right. I really need a better beverage for these live streams. So if you wanted to set up, I feel like I'm out of focus. So let's say you've got stock, you've got a bit 0. Let me load the tool back in so we can actually run through an example. So if you have a bit 0 bit setter, your workflow will kind of look like this. You're going to start in your home screen. Let me actually transition to this scene so you can see everything. So if when you first start up the machine, you're going to load a tool. It's going to go through the process of measuring that tool. So I'll just run through that now. It'll figure out what the length of the tool is relative to the carriages. It'll save that as an offset. So when you change a tool, it changes that offset. And then you can use your bit 0 to find the origin or like a corner of your stock. So don't forget to attach a grounding clip. Otherwise, just double check when you touch the bit 0. This turns red. Otherwise, you're going to have a really bad day. So then you can come over and then jog to roughly over that corner. I'm going to switch to millimeters just so I don't crash anything. And then here's the tricky part about a single flute end mill. I should have used a 3 flute or something. This cutting edge, let me zoom in. I don't know how well you can see that, but this point, the cutting point, is sticking out further than the center line of the tool, and the other side of the tool doesn't stick out as far. So this is an asymmetrical tool, which means when you find the corner, if the point of the tool isn't pointing the wall of the bit 0, you're going to have a false reading. So for maximum accuracy, you could take a 1/4-inch dowel pin or something and stick it in here. And that way, when the side of that dowel pin hits the touch probe, you know for a fact that it is 0.125 inches from that wall. A single flute end mill, or even a 2 flute end mill, will sometimes not give you a perfect reading because you might fall in one of the valleys of the flutes contacting the walls or the outer edge of the flute. So if you're picking up the edges, just make sure you point one of the cutting edges or the point of the end mill towards the bit 0. And then you can run through a probing cycle. I'm just going to probe in X. I'm just going to probe in Z just because it's faster. And our machinist is over here. Just here, you can say hello to our machinist. So he's over there, just glaring at me because I'm stopping him from machining. His name is Jerry. All right.
I was wondering why you were making a deeper voice.
I'm going to probe in Z. So if you're probing only Z, you actually set up the bit 0 differently. Instead of getting this lip over the corner and stopping it like that, you actually just place it entirely on top of the stock. And then you can probe only in Z, and that'll give you the top height. And then once you have your origin point set in X, Y, and Z, when you start a program, you load a new tool, touches off on the bit setter, and everything else just happens the way it should. Never forget to undo your grounding clip. Bad things happen when you forget to do that. Okay. Is there any videos you recommend for someone wanting to learn to machine aluminum with an double XL. I'll be honest with you, I don't watch enough YouTube to know too much else beyond the small circle of makers that I follow and the videos on the Carbide 3D channel. But I would say it's really just a matter of changing your speeds and feeds. So if your fundamentals of using a machine are, like if you practice on wood or plastic and those fundamentals are solid, you should be able to carry that over to machining any other material. So I'd focus on getting the basics down well, and then you can move on to more advanced materials, and it's just a matter of recalibrating your speeds and feeds and the expectation of the forces you're going to be putting back into the machine when you cut. Chip conveyor. Let me, I will make a note of that and submit that to my boss. Otherwise, this is your chip evacuation device. There you go. When probing only Z, do you have to have the bit hit the little circle, or can it touch anywhere else on the probe? So for those of you that don't know, there's a little target circle here. Don't know how well you can see that. Let's zoom in again. So the reason that circle is there is when the end mill, example, touches off on the top of it, if you're probing X and Y, it's going to do this. And if you start too far in, it's not going to clear the edge before it smacks into it. So you're just going to stab the end mill into the top surface. So that circle is there to give you a reference for where your end mill needs to be so that when it moves over and down, it doesn't plunge into your bit zero. If you're only probing Z, it can basically touch anywhere because this whole surface is theoretically coplanar. But I would recommend that you touch in this half of the bit zero because this is your contact area. So if you touch out here where it's unsupported, you're going to get a little bit of tipping. And that might not give you an accurate result, even though in theory it should. So just keep any Z probes on on this half of the bit zero. Okay. Let me check my Trello because I think we are pretty much okay. So yes, we can cut aluminum. People have asked if aluminum gets hot when you machine it. It will get warm, and if you're cutting a small piece for a prolonged period of time, it can get hot. A lot of it depends on how much mass you have in here. If you have like a little fan or a little compressed air blowing on it to help bring away heat and to clear chips, the higher your RPM, the hotter it's going to get. So if you need to run things cool, it'll take longer, but you can scale your speeds and feeds back for 10,000 RPM. It does build up heat. You are using a tool to literally rip aluminum atoms apart, and that's going to release energy. So it will get warm. If you're cutting something large, but the heat can dissipate out, that's fine. If it gets scorching hot, that's a problem, especially if you're using double-sided tape, because that tape, the adhesive gets weaker the hotter it gets. So you can work out maybe a shallow enough cut that you're putting less energy into your part. But if you have a large enough piece that will dissipate the heat at the rate that you're putting energy into it with your router, you should be okay. We talked about sound of a cut, and that is everything on my agenda. So I'm going to open up the chat, and let me know if you guys have any other questions. Can I use the 201 for aluminum? Yes, you can. In fact, that's how I started out. The thing about the 201 is that it is an uncoated cutter. In theory, it shouldn't matter. The difference in these coatings, which you can't see because the camera's not zoomed in, is one is gold and one is silver. The silver is the plain uncoated end mill. The gold is a zirconium nitride coating. So in theory, it makes it a little bit harder, a little more slippery at the molecular level, helps dissipate heat. But there's no reason that a plain carbide end mill won't be able to cut into aluminum just as well. This just gives you like a little extra safety net in terms of cutting successfully and not clogging your cutter. The other thing about this is because it's 3 flutes, there's 3 separate cutting edges. Each of the valleys in there, the flutes, is a little smaller. So if you're machining a deep pocket, chips might not get out fast enough. They'll start clogging this, they'll start fusing, they'll start melting, and eventually your cut will fail. So a single flute gives you more margin for error in terms of clearing out the flutes. Okay, can you 3D print with a Shapeoko? If you develop a 3D print head for this and the slicing software, you could totally run this as a 3D printer, but as far as I know, no one has done it. So let's see. You totally can use vCarve to create toolpath designs. So this goes back to a bigger discussion. You can basically use any software that has a post-processor that will export G-code that a Gerbil-based machine can understand. So Fusion, Vectrix vCarve, Aspire, Carbide Create Pro, Carbide Create, Meshcam, they will all work with the Shapeoko. Okay. X-axis belt on an original Nomad. I haven't dealt with that, but if you send an email to support, we can help you out on that. So, if there are no other questions, class is dismissed, but I will stick around in the chat for a couple minutes. After this concludes, I will throw basically a little waiting room image on this just to keep the feed alive for a couple extra minutes so you guys can chat with us if you want. But don't feel obligated to stay because that also means that I have to continue staying here. So with that, thank you for joining us. I hope you all are staying safe, especially in these really difficult times for this country. Be kind, be respectful, and have fun machining, folks. And, oh, excuse me, social distance. You know, we're twinning on these shirts.
Can I get back to work?
You can get back to work, Jerry. All right, take care, guys.